Okay, Assalamualaikum warahmatullahi wabarakatuh. On this video, I'm going to teach about the pH scale. So before that, let's review the learning objective. Okay, the first point is use pH value to distinguish between acidic, neutral, and alkaline solution. So based on the view of pH, okay, you should know how to identify acidic, neutral, or alkaline solution. Second, understand that pH provide a measure of the concentration hydrogen ion in aqueous solutions. Okay, so the higher the pH value, meaning that it have higher concentration of hydrogen ion. Okay, third is solve problem involving pH. So here there are a few formula that you have to memorize and understand the concept. Okay, fourth, write equation for the dissociation of water and state the expression of for Kw. So Kw here is a ionic product constant, and use the Kw values to work out the concentration of hydrogen ion and hydroxide ion and the pH of a solution. Okay, now let's go to the 8.3.1, the pH value. Okay, so what is the pH? pH scale can be used to indicate whether a solution is acidic, alkaline, or neutral. At 25 degrees Celsius, solution with pH lower than 7 is acidic, solution with pH 7 is neutral, and greater than 7 is alkaline. Okay, but you have to make sure that this is at 25 degrees Celsius, and if the temperature increase or decrease, it will affect the result of pH value. Okay, so the pH value are affected by temperature. Remember that. Okay, so this is a level of the pH. It starts from 1 until 14, and from 1 until 2, this is the strong acid, and 3 until 6 is a weak acid, 7 is a weak acid, 7 is neutral, and 8 until 12 is a weak base, 13 until 14 is strong base. Okay, alright, so next, okay, the pH of solution can be determined by using a pH meter or by using a universal indicator solution of paper. So this is apparatus that we can use to measure the pH. And pH is a measure of the concentration of hydrogen ions in a solution. The concentration of hydrogen ions can be stated in mole per centimeter cube, but the use of log 10 function simplifies the numbers involved. Okay, definition: pH is the negative logarithm to base 10 of the hydrogen ion concentration in an aqueous solution. Okay, what is meant by this statement is, okay, actually the pH value is related to the concentration of hydrogen ion. Okay, so I will explain it later. So if the concentration of hydrogen ions in solution is 1.57 times 10 negative 3, the pH is worked out as, okay, so this formula, okay, so on this topic, this is your first formula that you have to memorize it, which is we can calculate the pH value if we know the concentration of hydrogen ion. Okay, in this case, the concentration of hydrogen ion is 1.57 times 10 negative 3. So what you have to do is pH is equal to negative log bracket 57 times 10 negative 3. Okay, just use your calculator and you will find that the pH is 2.80. Okay, I suggest that at least use 3 significant figure as your pH value. Okay, don't run off. Suggest 3. I'm not suggest you use a 3 value. Okay, don't round out the value. Okay, next. Okay, make sure the pH, there is no unit of your pH. Okay, just value only. Okay, now how to calculate the hydrogen ion from a pH? Okay, before this, we can calculate the pH value if we know the concentration of hydrogen ion. But the second formula is we can calculate the concentration of hydrogen ion if we know the pH. So the formula is concentration of hydrogen ion equal to 10 power of negative pH. Okay, please look at on this table. Okay, this table have a list of pH. Okay, 0 until 8, but actually it until 14, right? Okay, what is mean by pH? Okay, when pH increase one level, increase one level, and increase one level, it is equal that the concentration of hydrogen ion increase 10 times. Increase 10 times, right? When pH increase from 1 until 2, meaning that the concentration of hydrogen ion increase 10 times. When pH increase from 2 to 3, it increase 10 times, okay? And so on. Okay, let's say pH is 0. Okay, pH is 0. Okay, so when pH increase from 0 to 1, 0 to 1 is equal to 1 times 10 negative 1. Okay, this is formula how to calculate the pH concentration of hydrogen ion when we know the pH value. Okay, if the pH value is 1, so 1 times 10 power negative 1. Okay, okay, let's say the pH is 2. If the pH is 2, okay, is by using the formula 1 times 10 power of negative 2, so it equal to 0.01. Okay, the higher the number of pH value, the smaller the amount of hydrogen concentration of hydrogen ion. Okay, so when the pH is 0, concentration hydrogen ion is 1, meaning that this is 100% concentration of hydrogen ion. Okay, the higher the concentration pH, the lower the concentration, right? So this is the relationship between concentration of hydrogen ion and pH. From pH we can calculate the concentration of hydrogen ion, and from concentration of hydrogen ion we can calculate the pH value. So now we have two formula. Okay, right. Okay, let's do a few exercise here. Okay, calculate the pH of 0.100 mole for the center cube solution of hydrochloric acid. Okay, now we can calculate the pH if we know the concentration of hydrogen ion. Okay, and don't use directly the concentration of hydrogen ion. Okay, this is strong acid, right? Okay, so strong acid aqueous, it will ionize completely to produce hydrogen ion and chloride ion. Okay, it ionized completely, meaning that this is monoprotic, so 0.100 HCl equal to 0.100 hydrogen ion. Okay, now we know the concentration of hydrogen ion, so pH equal to negative log bracket 0.100. Okay, then use your calculator and your answer should be 1. Okay, okay, next calculate the pH. Okay, from the concentration nitric acid. Okay, on this question the concentration of hydrogen ion are not given directly, but you have to use a ratio to find the concentration of hydrogen ion. So nitric acid is a monoprotic, HNO3 aqueous. Okay, in water it will ionize to produce hydrogen ion and nitrate ion. Okay, so 1.00 nitric acid. Okay, this is initial. Okay, this is initial concentration. Okay, second changing of concentration, meaning that minus 1.00. Yes, of course, minus 1.0, because nitric acid lost completely. Okay, it ionized completely, right? So it will reduce its concentration completely. Now this is plus 1.00 plus 1.0. I hope you all can understand my methods. My method is, okay, during the reaction. Okay, this is before reaction. Reactant have concentration, product there is low concentration. After the reaction is proceed, okay, reactant, value of reactant will become 0. Yes, minus it will lost based on its concentration lah. Okay, and now the concentration of product plus 1.00 plus 1.00. Okay, so the final concentration is, yes, reactant becomes 0, and this is the concentration of hydrogen ion. Okay, this is the formula. Okay, now this formula is quite important when you want to calculate the concentration hydrogen ion for weak acid. Okay, but you all can try to do this formula. Okay, now our concentration of hydrogen ion is 1. Okay, now concentration of hydrogen ion, okay, pH equal to negative log bracket 1.00. Okay, and the answer is 0. Okay, meaning that this is strong acid. Okay, strong acid and very high concentration of hydrogen ion. Okay, third, calculate the pH. Okay, for the 0.25 mole per centimeter cube solution of sulfuric acid. Okay, so as usual, write the half equation, chemical equation. This is aqueous. Okay, ionized completely in water to produce 2 hydrogen ion, aqueous plus 1 mole of sulfate ion, aqueous. Okay, so for the initial concentration, bracket is concentration, right? Okay, 0.25 mole per decimeter cube. Okay, for the initial product is 0 concentration, and the changes of concentration. Okay, if the acid ionized completely, we have to minus with its concentration. Product, okay, plus 0.25 minus 2, because there are two atom here, 2 ion, okay, and plus 0.25. So finally, the final concentration, okay, sulfuric acid now 0 because it completely ionized, and this one is 0.50. Okay, this one is 0.25. Okay, so what is the concentration of hydrogen ion? Concentration of hydrogen ion is 0.50 molar, and pH is equal to negative log 0.50. Okay, then use your calculator. Okay, this is the pH for sulfuric acid. Okay, alright, so that's all for my video about the pH scale. Thank you.